Good morning. I thought maybe we would do a little video today on how to solve systems algebraically. So yesterday we solved systems graphically. As you recall, where the two graphs intersected is where the solutions were found. Okay, so algebraically, in order to find where these two functions intersect, we're going to go ahead and set them equal to each other. Since both of these equations are equal to y, we can substitute this function into the other function for the y value. So we're going to look for where these two functions are the same. What do they have in common? And so we're going to go ahead and solve for x. Remember, when solving a quadratic equation, we want to set the equation equal to 0. So I'm going to go ahead and eliminate these two terms on this side. Hopefully we're getting really good at solving quadratic equations. So at this point, we could try factoring. We could try quadratic formula. Let's go ahead and try to factor it first. You can tell easily if it's factorable by using the discriminant. You could possibly do that in your head. Square the b, you get 100 minus 4 times 1 times 21, and you get 84. I'm sorry. So we get 100 minus 84, which comes out to be 16. Since that is a perfect square, we know that we're going to have two real solutions, and they're going to be rational. If this had turned out to be 17, that's not a perfect square. We'd still have two real solutions, but they would be irrational. And remember, if it turns out to be a negative number, then we'd have two non-real solutions, and it would turn out to be complex. So we know we can factor this because we've got a perfect square here. So a times c, b on the bottom. Finding our two numbers, looks like -7 and -3 are going to work for us. Put our a value on top. Write down our two factors. Remember, this is set equal to 0, so we just went from standard form to factored form. Solving in factored form, we set each factor equal to 0. And hopefully, by now, you could probably do this in your head. We have x equals 7 and x equals 3. So our two solutions are going to have x coordinates of 7 and 3. Remember, this is a parabola, and this is a line or linear function. So they could have two solutions, they could have no solutions, or they could have just one solution. So let's go ahead and see what our solutions are going to be. So one solution is going to be 7 something, and the other solution is going to be 3 something. So to find that other something, the y-coordinate here, we're just going to plug the x values back into either equation. You're going to get the same answer. I'm going to put it into the easier one. So plugging the 7 in here, we have 10 minus 14, which is negative 4. Plugging the 3 in, we have 10 minus 6, which is 4. And so these two functions will intersect. Remember, that's where the solution lies. The intersection will be at these 2 points right here. Remember, if the variable vanishes when you're doing this, then you have to compare your two numbers to see what you have here. When you have a quadratic and a linear, remember, you can't have an infinite number of solutions. You can either have 2, 1, or no solution. Graphically, 2 solutions, you have your parabola, and you have your line going through it. One solution, you have your parabola, and you have a vertical line that goes through it at some point. And no solution, you have again your parabola, and you have your line that does not intersect it at all. And this is the instance when the variables would cancel, because they wouldn't have any x in common on those. Okay, so that is solving systems algebraically. I'll see you guys in class tomorrow.